Hello everyone and welcome. My name is Eric Coleman with IIST and I will be the moderator for today's webinar, Software Quality Management, a Proactive Approach by Robin Goldsmith. We're excited you're able to join us today and set aside an hour to attend this webinar. This webinar is one of a series of free webinars to introduce the topics as well as the presenters of the upcoming SQTM conference in San Diego, California, September 13th through the 18th at the Sheraton San Diego Hotel and Marina. The conference focuses on advancing the test management and quality management professions by providing practical methods based on best practices. The ongoing theme of the conference, Practical, Proven, Feasible, keeps the focus on what works. To view the conference program and more information, visit www.qualitymanagementconference.com. Be sure to join us for the next webinar in the series, Managing the Test Process, a Proactive Approach by Robin Goldsmith, on May 26 from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to www.qualitymanagementconference.com. This webinar is being recorded and will be made available for viewing within 48 hours at www.qualitymanagementconference.com. I will now turn the webinar over to today's presenter, Robin Goldsmith. Robin?
Thank you, Eric. Welcome, everybody. Quick pack of lies about me. I work directly with quality professionals and train and consult in a bunch of areas that I see as all related: requirements, quality and testing, software acquisition, process measurement improvement, ROI, and so forth. I see these all as aspects of helping organizations get what they need. Once upon a time, I had real jobs and spent a lot of time picking up a bunch of degrees. Been a member of two IEEE standards working groups, one for IEEE Standard 829 for software test documentation, and the other just recently completed IEEE Standard 730 for software quality assurance. And we're going to be referencing some of that in this. And I'm pleased with the concepts of my proactive software quality assurance approaches, and were incorporated in the major revision of IEEE Standard 730 on software quality assurance that came out in 2014. I am was a subject expert on BABOK version 2. BABOK version 3 has just come out, and I'm also a subject expert in requirements and quality and testing for search software quality on techtarget.com. And I do have a book called Discovering Real Business Requirements for Software Project Success. I'd certainly encourage you to check that out. It's related to what we're talking about today, although it's not specifically the topic of software quality management. Excuse me. What we're presenting today is a preview of a full day seminar that I will be presenting at the SQTM conference in September. So, and Eric has already pointed out that you can find out more about that at thequalitymanagementconference.com or IIST.org's website. So let's get into what I hope to accomplish in the next hour or so. And first of all, we want to make some distinctions. We want you to be able to make some distinctions between system and software quality, and system and software quality control, and system and software quality assurance, and system and software quality management. So there's really two types of distinctions between the system versus software, and then quality control, quality assurance, quality management, and how that just differs from quality in general. I'm going to describe to you what I call proactive software quality assurance, and specifically the 6 functions that it should perform, and then relate that to the 5 elements of what I call proactive software quality management, and see how quality management and quality assurance, these terms, some people make distinctions, some people don't, so we're going to be delving into that. So you folks are going to get to do some work here, And so I'm going to ask you to actually send on the questions as opposed to the chat button. It's somewhat confusing here because there are two, but let's use the questions facility. And what I'd like is for you to let me know what you mean by system quality and what you mean by software quality. And if you can, why it matters how you define system quality and software quality. And if there are any issues with how your organization either does or does not define them. So if you would chat that, I'm going to flip back into PowerPoint here so that I can capture what you're saying. So I'm going to stay here until you contribute, and this, I think you'll find that your contributions will make this more interesting for everybody and more informative for everybody. So let's find out first, what do you mean by system quality? So please chat that if you would, and while you're identifying that, I'm going to tap dance, as the saying goes. Terms like this, in my experience, people often use these terms without thinking very much about what they mean by them. They assume that they know what they mean. They assume that everybody else knows what they mean, and that everybody else uses these terms the same way that they do. And somehow or another, that doesn't always work. So if you would, please send questions in the question box, your definition of what you mean by system quality versus software quality. So your participation is going to really help this session go a lot better. So please type that into your question box. There we go. We're beginning to get something now. And okay. So let me see. System quality would go beyond just the code aspects. That's from Kristen. System quality covers the application and how it works well with other applications. Okay, so let me just see if I can capture some of this, and I'll caution you that my computer tends to make a lot of mistakes when I type, so goes beyond the code. Let's see, applications, and what was the verbiage there? Just on the application, overall quality of the complete system, whereas software is just software. So, okay. So complete system, software is just software. I apologize for the fact that I have to kind of go back and forth to the chat box or the question box. So software is a subset of systems quality and would include documentation quality, whether the test reports, requirements, etc., or user documentation quality. So let's see, and somebody else said system quality would include accessibility. Let's see, there's one of those problems that my computer made. Okay, accessibility. When customers need it, security performs as expected. Okay, now here's somebody that says it is the quality of the code. Okay, so quality of the code. Okay. Quality of the product. Whoops, not the code. Nor product. Okay. And people have said that software quality is just the software. Okay. So so we had a thank you for your contributions there. That's very helpful. So basically, I think people generally agree that software quality is possibly a subset of system quality. And that one of the things that really differentiates system quality from software quality is that it includes hardware and software. And okay, then other things like documentation and so forth, I wasn't quite sure where that was, but documentation may be included in software quality, but some people would consider that just part of system quality. So go back to the full screen. So hopefully this is in line with what you were saying there. I hope I've captured it fairly adequately. And what's it matter? What's it matter how you define these things? Well, if you don't really know what you mean by quality, or you're using terms somewhat interchangeably or loosely, then there's a good chance that you get misunderstandings and things fall through the cracks, none of which is actually going to be serving the interests of quality. And very often these problems are, or these issues are organizational. That is, that the organization hasn't really come to grips with the terms that it uses. Now, in some organizations, there's a big distinction made between system quality and software quality. And in other organizations, they're just kind of treated as part of the same thing. So it matters, because if there's a big distinction, there may be separate organizational groups dealing with system quality versus software quality. So from a standpoint of quality control and quality assurance, quality management, the decision whether or not a solution includes hardware is really a design decision. In other words, the difference between hardware or hardware and software or just software is not a requirements issue, it's a design issue. Okay? And if the organization makes distinctions about things, whether or not it's expected to use hardware, If that determination is made inconsistently or incorrectly, then things are going to get out of kilter, because if you've decided that something has a hardware component or is going to have a hardware component, and you're putting activities and responsibilities in different buckets, different organizational groups, you're doing that before you've actually reached the design point when you have sufficient information to determine whether the solution is a hardware or a software solution, system or software solution. Okay. And so prejudgments like this can create organizational issues when the organization makes a big distinction between these. And if there is a subsequent change in determination of whether something uses hardware or doesn't use hardware, it can affect the design, it can affect the requirements, it can affect how the thing is actually built. And these are issues that you need to be concerned with. So the first thing that I would encourage you to do is to realize that the difference between system and software quality, the difference between using hardware or not using hardware as part of your solution or considering hardware as part of your solution, is a decision which is made downstream in the design process and is not something that should be, that you should put much stock in while you're identifying requirements, or even in the early parts of design. Okay. And I would also question whether this distinction is actually relevant or useful. That I think that a lot of organizations that have, for instance, separate functions or separate groups based on whether something is expected to be hardware or expected to be just software, really are inviting opportunities for mistakes. So I'll caution you about that. Now, quality is the key to delivering things quicker and cheaper. And some of you may be familiar with the term quality is free, which was actually the title of a book by Philip Crosby, who's one of the three big total quality management gurus. And Philip Crosby had a special meaning here, because what Crosby meant was that quality is what you need to end up with, and that the cost of quality is actually the cost of poor quality. So he's kind of being artful here, taking some literary license, and he's saying quality is free and that you've got to end up with that, and what you need to pay attention to are all of the costs of poor quality. So the costs of assessment or appraisal, what QA and testing people generally are doing. The costs of prevention, which QA often addresses. And the costs of failure. In other words, what happens when that poor quality gets to the field, gets out, or is detected in the development process. Because there are internal failure costs, primarily those related to the developers rebuilding things and having to retest them, and you know that that constitutes a major portion of most projects. But there are also external failure costs, the costs when a problem actually gets out to the users. Now, perhaps you heard on the news that a leading manufacturer of airbags in automobiles has just been pushed to recall something like 33 million airbags. I mean, that can really ruin your day. That's an enormous obviously an enormous financial hit for the airbag vendor who has to go fix all those airbags. There's a good chance that that airbag vendor might go under rather than actually pay for all those fixes. And it means that there are prospectively or tentatively 33 million of us driving around with an airbag that could kill us rather than save us. Those are external failure costs. Those are pretty significant. The software development folks tend to be more conscious of the internal costs, especially the ones that are incurred during the development process before we go into production. So we talked about system quality versus software quality, and we said the distinction is largely whether hardware is included or just software. But we kind of, in that, didn't really get to the other word, quality. And so I want to suggest, or not suggest, but list a number of common definitions of quality. These are not mine, these are from other people, and many of you may be familiar with them. So, and let's look at each of them very quickly and see if there are any problems with these definitions. So, customer satisfaction. A lot of people say quality is customer satisfaction. Well, I'm going to disagree. I think customer satisfaction is presumed to be a result of good quality, but it's not the same as good quality. And in fact, customers can be satisfied with poor quality, and sometimes they're not satisfied with high quality. So customer satisfaction is not the same as quality. A lot of us use the definition of meets or exceeds customer expectations. Okay. Now, this is certainly somehow related to quality, but once again, what's the issue? What are those customer expectations? Does the customer expect something that's reasonable? If a customer expects something to be lousy, their expectations can be satisfied to an extreme, but that's still not high quality. That's not quality. If a customer is satisfied with low quality, or with expecting low quality, it's still low quality. And if they expect quality that is beyond reasonable, okay, their expectations are not going to be met, even though there might be high quality. Some people use optimization or value, okay, and those are not exactly the same, but optimization is optimization. It's not quality. It's related to quality, but it's not quality. It relates to how much it costs you or how efficient things are. But that's not the same. That may be an element of quality, but it's not the same as quality. Value is not quality. Value is related to quality because quality presumably provides value. But the value that's provided is not the quality. It's a consequence of quality. Okay? Related but not an accurate definition. Perhaps the most widely used definition of quality comes from Philip Crosby, whom we mentioned a minute ago. Conformance to requirements. It's a good chance that many of you use this definition or something similar as your definition of quality, what you mean by quality. Now, the problem is that it doesn't address the adequacy of the requirements. Conformance to wrong requirements is not quality. So if the requirements are not right, or not accurate, or not complete, conforming to them will not produce quality. So you need to get to both aspects, not just the conformance, but also the requirements themselves. There are a number of statistical definitions. Deming, W. Edwards Deming, another of the total quality management gurus, who's big on statistical approaches, although he doesn't specifically like inspection as a means of assuring quality. But lack of defects is related to quality. That is, if you have something that's got a bunch of defects in it, that indeed diminishes the quality. But just because you haven't detected a defect doesn't mean that the thing is suitable quality. Part of it can be, once again, the definition of what constitutes a defect and the adequacy of your defect detection activities. And it should be no surprise that most of us have a lot of room for improvement there. The related statistical type of definition comes from Six Sigma, where Six Sigma talks about quality in terms of variation within a specification. Well, variation is something that is also related to quality. But if the specification is not right, variation within the wrong specification is the least of your concerns. And Joseph Duran, the third of the big total quality management gurus, said fitness for use. And in many ways, fitness for use is probably the best of these definitions, but it still gets to the question of what uses and what do we mean by fitness. So if the uses are not defined appropriately, if the definition of fitness for those uses is not defined appropriately, then you've still got a problem with regard to how you define quality. So what's the message here? That if we don't know what we mean by quality, or if what we mean by it is not appropriate, then we're going to have a real difficult time producing quality. And as long as we don't have a common definition, okay, then everybody's going to be disappointed and everybody's going to be finger pointing at the others. Okay? And each one thinks that the other one doesn't care about quality. So, and we can't manage what we're doing. We need to have things defined. So I want to bring in some additional information that I think is valuable for coming to a more workable, more useful definition of quality. And this relates to what are called quality dimensions. Quality dimensions, there are 3 quality dimensions. And these are not concepts that I invented. These have been around for, I'd say, more than 100 years. They come from classical quality control, long before information systems reared their heads. And so there are 3 quality dimensions in this view. The first is quality of design. Now, quality of design is what's it need to do, and to some extent it incorporates both requirements and design. So, you know, what it needs to do in terms of functionality and capabilities and performance levels and so forth, that the design suitably meets those requirements, the costs and benefits are accurate, and the trade-offs are reasonable and based on adequate information. The second quality dimension is quality of conformance. This relates to how things are produced. This is what most testers are doing, is determining that the products conform to the design. Quality of conformance also relates to the standards and conventions and worker and management practices that are applied, and it includes delivery on time and in budget. Because if something is not delivered on time, then we don't get the value of it as much as we would prefer. And if it ends up costing more than we were prepared to pay for it, then we are deprived of other judgments. Possibly we might have made an alternative approach rather than the one that we did, because the costs end up higher than we were intending to pay. The third quality dimension is quality of performance. This relates to the delivery of the product, including availability, actually working, being reliable, working accurately, handling workloads, and then being supported and maintained responsively. Now, in my experience, when people talk about quality, they're often talking about it from a quality of conformance perspective, a testing perspective. And as we said, that's only going to be as adequate as the quality of design, which is often not right or not adequate. And the quality of performance is very often overlooked, left out of the equation. So quality dimensions are one additional element that we need to take into account to help us understand about what quality is. Another element that we need to take into account are quality factors. Now, quality factors are often referred to as non-functional requirements, because quality factors are things like usability and reliability and so forth. Okay, and quality factors can be interior or exterior. They're very often referred to as illities. Now, what I want you to realize is that a lot of people refer to these quality factors as non-functional requirements. That's deceptive, that's misleading, because these quality factors only have relevance with regard to functionality. And some people refer to these, the quality factors, as quality requirements. And that's also a mistake, because the biggest element of quality is the business deliverables, the application functioning, not the illities, but what it actually does. And the ones at the top tend to be what are called exterior factors. Exterior factors are primarily visible to and of concern with the user. The ones at the bottom are interior or engineering factors. They tend to be more of concern to the engineering side. And then some of these relate to futures, so maintainability and supportability and so forth. Okay. Those are future factors. So if you leave out any of them, you're going to be overlooking quite possibly some important elements of quality. So when we put these two pieces of information together, here's how I see them fitting together. That we have the quality factors that describe how well something is done, but they're only relevant in the context of the business requirements. And business requirements basically describe capabilities. So how much is done. And so we capture the how well in engineering standards, and they pertain, you can have engineering standards that pertain to quality of design, to quality of conformance, quality of performance, and we tend to see them in separate parts of the development process. So we tend to see the quality of design elements in the analysis and design activities. We tend to see the quality of conformance regarding development and testing the developed systems and software and products. And then we see the quality of performance coming into play once that product or system is operational. So when we put all of this information together, we come up with what I suggest for a working definition of system quality. And so quality is the extent to which the system meets weighted, stated and implied, exterior, interior, and future real business requirements, and we'll talk more about them in a second, okay, real business requirements, okay, of all affected internal and external stakeholders, consistent with standards of design, workmanship, and performance. So I think that that big mouthful actually gives us a much more accurate definition of quality. And I use as a shorthand version of that, the quality means that it meets real business requirements consistent with standards. Real business requirements are from the perspective of the business, the user, the stakeholder. They are business deliverable whats that, when delivered, provide value. They provide value by achieving objectives, and they provide value only when they are actually satisfied by some product, system, or software. So the product, system, or software is the means for satisfying the real business requirements. And the real business requirements include relevant standards of design, workmanship, and performance for both internal and external stakeholders. So hopefully that's an understandable definition, and that I hope that you will find that it's a more useful, more workable, more effective, more relevant definition of quality for our product, systems, and software. Now, once we define quality that way, then we can see that the more of the relevant requirements that are met, the higher the quality. And the more demanding the standards are with respect to meeting those requirements, the higher the quality. So the how much and how well interact. They work together. And quality is absolute. Quality is an engineering concept, and it can be measured by the extent to which something meets the real business requirements consistent with standards. That's an absolute. What varies is not the quality, but the amount of that quality that somebody actually gets. So the quality is determined from an engineering perspective. How much of that quality you actually get is going to be governed by your available resources, other constraints, and your priorities. So, in other words, if for the sake of argument you say that a Rolls-Royce is a higher quality car than a Chevrolet, there's a lot of people that say, but I can't afford a Rolls-Royce. So they don't get the Rolls-Royce quality, but that doesn't change the quality of the Rolls-Royce. It just changes what they are able to get. And value is the perceived benefit of the quality received relative to the costs of producing and receiving it. So hopefully these definitions are understandable, and hopefully you can see the benefit of defining quality in this way and relating it to value, and seeing that quality is an engineering and a measurable engineering concept, and that what varies is how much quality you actually receive, not how much quality there is or could be. So hopefully that's understandable. If you have questions, please do type them in the question box, and we'll look at them in a few minutes. So let's go on and look at some other aspects. So these three terms: quality control, quality assurance, and quality management. And I'm going to suggest that whether it's for systems or software or both isn't really an important distinction at this point. But what's the difference between quality control, quality assurance, and quality management? And so once again, if you would, please type your definitions or your distinctions, if you will, of quality control, quality assurance, and quality management in the questions box. So please type that in now, if you would, and so once again, is there a distinction that you make? If there is a distinction, what is the distinction? And then we'll examine briefly what difference it makes. Okay. So any thoughts, anybody? Please feel free to chat. I'm not going to try to type your answers in because I'm kind of going slow at that, and I don't want to bog us down too much. Any thoughts here? Okay, so thank you. Let's see. Oh, good. We've got a couple of answers here, and I apologize, but my questions window is really kind of small, and I'm only seeing one line at a time. I don't know how to adjust it, and I don't want to mess things up here. So, quality control goes on during evaluation. QA, how you represent that you controlled it. Okay, that's an interesting distinction. Quality control adheres to standards to meet certain criteria. Okay, and let's see. And let's see. Okay, so QC is performed by testing, QA is performed by QA, and SQM is the management of both QC and QA. Okay, good. And quality assurance is methods and process or engineering. Oops. Let's see. Where'd it go? Let's see. So quality assurance is methods and process or engineering team used. QC is related to testing, while QA includes testing and processes, and QM covers developing a strategy out of metrics to make directions for the entire project or organization. Okay, so, well, very good. Thank you for your contributions. So, it seemed that there was agreement that quality control is testing, and that QA is something else. Okay. May include testing. Some sounded like some of you were saying that QA included testing. Some of you didn't mention that. And quality management seemed to be related to both quality control and quality assurance. So I would agree that quality control, or that testing, is a form of quality control rather than quality assurance. And one of the things that we see is that there's a lot of organizations that use one of these names and don't distinguish it from other stuff. Now, the most common that I encounter is that folks are called QA, but that what they're actually doing is primarily testing. And I find that some organizations do have separate testing and quality assurance groups. Many organizations don't. Now, here's the issue. If you've only got one of these things addressed, then there's a good chance that things that reasonably would fit under one of the other terms may well fall through the cracks. They may get missed. That's a very common thing. So when an organization has calls what they call QA is actually doing testing, there's a pretty good chance that they're not doing QA and they're not doing quality management. If they've got separate testing and QA groups, then the folks called QA are typically doing something other than testing. Whether it's classical QA, that may be a different issue. Okay. So what often does happen, though, is that when there are separate groups, a separate group for QA and a separate group for testing or QC, or a separate group for quality management, which is much less common in my experience, well, what happens? It's real easy to get into turf wars and bureaucracy. Some things get duplicated and other things tend to fall through the cracks. Okay? And that's no big surprise, because what happens? Each group assumes that something is being done by another group, and in fact, oftentimes, that's not the case. So let me give you a brief introduction to some IEEE standards and lead us into proactive software quality assurance. So IEEE, Institute for Electronic Engineering, is a professional organization of over 400,000 members worldwide. One of the things that they do is that they develop standards on a variety of engineering topics, including information systems and related quality and testing. They have an overarching standard, 12207, for life cycle processes. And so I just want you to be aware that in IEEE standard 12207, in section 6, called project enabling processes, they have quality management. So they consider that an organizational project enabling process. And then within software specific processes, they have what they say is qualification testing. That's quality control or testing as we know it. And then as a software support process, they have software quality assurance. So IEEE Standard 12207 makes a distinction among these three. It explicitly identifies each of them and positions them somewhat separately. Okay. Now, it's very common in my experience that especially QA often is done in conjunction with some other of these support process functions. So QA might be done in conjunction with configuration management or version control. That's a common thing. Or in conjunction with audit or verification and validation. So they're organizationally, a lot of folks lump these things. That doesn't really make a difference. It's just that you may be using some slightly different terms. But the classical definition or the classical distinction is that testing examines products, typically end products, but it's examining products, typically for conformance to specifications, which in turn are often referred to as requirements. That's what testing is. Dynamic execution of the code is testing to examine the end product, the working software, whether it conforms to the specifications. Quality assurance should be assuring that the processes producing those products are in fact producing quality products. Okay. Now, in many organizations, that's interpreted as meaning examining intermediate products within the development process, primarily reviews of requirements and designs, documents. That's probably the most common way that organizations that do make a distinction between QA and testing, they tend to say that QA is involved with reviewing documents and testing is involved with executing code. And very often that review of documents is more of a traffic cop to check compliance to some kind of formats or standards or guidelines. Now, what I want you to realize is that examining intermediate products, including various documents, is actually quality control as well. So whether something is an end product at working code or an intermediate product, requirements, designs, procedures, and so forth, they're still products. And so what most people distinguish is really actually just another form of quality control. A fine point perhaps, but what's the significance? It means that folks that are called QA are actually doing QC, and that real QA or classic QA is probably not getting done. So I want you to realize where quality comes from. It starts with how well quality is defined, and then how well it's implemented, and then how well testing detects defects that do exist. So in terms of impact, the most important, biggest impact on quality is how well it's defined. The next most important impact on quality is how well the developers implement product systems and software to fit the definition of, the quality as defined, requirements basically. And the least impact, the lowest impact on quality is testing to detect defects that do exist. However, in terms of effort expended, we spend far more time on the lowest impact testing activities and far less time on the highest impact defining quality issue aspects. And we tend not to spend much effort, well, developers spend a lot of effort developing, but we don't tend to spend a lot of effort assuring or giving them means to assure that they're developing effectively or adequately. When we get proactive with regard to software quality assurance, and this is the direction of the updated IEEE Standard 730, then we see that we need to address the process to make sure that there are appropriate methods and techniques identified, and to make sure that they are used well, and that we need to make sure that the projects are in fact producing, using appropriate methods and techniques and using them well to create the relevant software products, which includes both intermediate and end products. And then we also need to make sure that the products that are produced are in fact that the delivered software in fact works properly. Okay. And that's the testing. Now, in terms of value, the greatest value comes from making sure that the processes are defining appropriate methods and techniques and that they are being used well. The next most important value comes from making sure that the methods and techniques were being used appropriately. And the lowest value comes from testing the delivered code. But once again, when we look at where people actually spend their time, it's testing the delivered code that people spend the bulk of their time on. So, proactive software quality assurance is establishing an environment that promotes quality. It's cradle through grave. It's defining when and what and how to test. It's addressing design and workmanship and management practices, not just testing code. And it's looking at ways to improve and prevent errors. But at the heart of it is quality control. Ultimately, you need to ascertain whether the various products, intermediate and end products, are being produced suitably in order to produce necessary quality. So there are 6 functions of proactive software quality assurance, defining what are called quality assurance plans, which are project plans that define what to do, and defining the methods and practices and standards to do it well. To make sure that there are appropriate quality controls of both processes and products to make sure things get done right, maintaining records to keep track of what's happening, analyzing and reporting so we can learn from our records, and then actually directing attention to improving quality, to encouraging it. Now, proactive software quality assurance says that your quality assurance process needs to make sure these things get done and done well. It doesn't say who should do it, and it absolutely doesn't say that all of it should be done by somebody with a title of QA. What it does say is that QA has a responsibility to make sure that the organization's processes actually do these things. Okay. So those are the 6 functions of proactive software quality assurance. In my experience, as practiced, quality assurance tends to shortchange a bunch of them and doesn't really give them justice in many instances. Conversely, managing software quality means identifying how to create quality, assuring that the methods and processes for creating quality have been used effectively, assuring that there's suitable software with suitable quality coming out of this, and being supported, not just being delivered, but being supported, improving the methods and processes for both creating and evaluating software quality, and balancing the costs and time of sufficient or free quality with the costs and time of poor quality. So these are the 5 aspects of software quality management as I see it. And to my thinking, proactive software quality assurance and proactive software quality management really are talking about the same thing. And that the only instance where it makes any, where distinguishing has any value is if you've got separate organizational units responsible for these different activities. So essentially, proactive software quality assurance says make sure all these things get done, and some of them may get done by folks with different titles. Proactive software quality management says the same thing. Okay? And that it's for both systems and software. So proactive software quality assurance includes proactive software quality management, and proactive software quality management includes proactive software quality assurance. Okay. So I hope that you found that we've done what we set out to do, that we've made some distinctions between system quality and software quality, and that that's by and large an artificial distinction based upon design decisions of whether or not the product includes hardware as well as software elements, and that premature judgments on whether it's a system or software quality issue can actually interfere with meaning, that quality control is examining products, quality assurance is examining processes, and as I use the terms, proactive software quality assurance, which has 6 elements or 6 functions, really overlaps completely with the 5 elements of proactive software quality management. And so I see them as 2 views of the same thing. So hopefully this is understandable. We're going to get to some questions in a second. Just want to remind you that the International Conference on Software Quality and Test Management will be September 13th through 18th at the Sheraton San Diego Hotel and Marina, a really gorgeous place right across from the airport in San Diego. Just an incredibly beautiful place. And also a very, very jam-packed conference with lots and lots of tutorials, including 3 that I'm doing and many others, and a full day of track sessions as well. And that in fact, this webinar previews one of my full day seminars, the one on software quality management, which will be on Monday, September 14th. If you need to contact me, my email is robin_goldsmith@iist.org.
Thank you, Robin, for your time today, and thank you to everyone for joining us for today's free webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit www.iist.org. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day.